what normal trig functions are. We have learned what normal trig functions are. So as we talk about inverse trig functions, well, does anybody know what the word inverse kind of means for math? It means the opposite, right? We talked about inverse operations before. So like, what's the inverse operation of addition? Subtraction. The inverse operation of addition is subtraction. I left my pen at my desk. I have to go grab it. I know. Getting my steps in. I kind of want my Fitbit. No. That's right here. See, I have the new invisible skin on it. Okay. So the opposite of addition would be subtraction. The inverse of addition would be subtraction. Okay. Can anybody tell me another pair of inverse operations? Bree? Multiplication and division, okay? That's another pair of inverse operations, because just like addition undoes subtraction, subtraction also does addition, and multiplication undoes division, and division undoes multiplication. Anybody think of another pair of inverse operations? Quentin? Squaring something, so like taking x and squaring it, and what's the inverse? Square rooting something. So squaring and square rooting something are going to be inverse operations as well. Squaring and square rooting something are inverse operations as well. Yeah? So that's not inverse operation, that's perpendicular, but I'm happy you remember that. Okay, thank you for throwing that out there. It is an opposite in math, yeah, but it's a different kind of opposite. So these are opposite operations, whereas that's the opposite sign. That's a good point, though. It is somewhat opposite. So we're talking about opposite or inverse operations. So in math, anytime you have an operation, we're able to undo it. It's never just a one-way street. We're able to undo it. Well, trig functions are still operations, just like all of those, just like only have an angle. But we can undo it as well. We can undo that operation as well. So we have these special inverse trig operations. So if sine of angle A is equal to x, sine of angle A, we always take sine, cosine, tangent of an angle. If that's equal to just sum x, could be like that 3 over 5 we had on our homework, something like that. If sine over A is equal to x, then angle A, the measure of the angle, is equal to the inverse sine of x. Whoa. Okay, so there's some things to talk through here. There's some things to talk through on this. First, when we do the inverse sine, we end up getting the angle by itself. So just like after you add and subtract, you end up getting, if you add and subtract the same number, you get the original number you had, right? Or if you multiply and divide by the same thing, you get the original number you had. So if we take the sine of an angle, and then we do the inverse sine, we get the original angle we had. We get the original angle measure. This is an angle measure that we get with A. Second thing to talk about here is this sine to the power of -1. That's how it's written, but it's read and it means inverse sine. So just like addition and subtraction are inverse operations, sine and inverse sine are inverse operations. That's just how we write it. We just write that, sine to the -1, which just means inverse sine for us of x. And so we take that of this side. Now mathematically how that would work, walk through mathematically how this would work. If we had sine of angle A is equal to x, and I wanted to get this by itself, if I want to get angle A by itself, I need to undo the sine to get it by itself. I can't divide by sine because sine is not multiplying with A. We're taking the sine of angle A. So I need to undo the sine. So to undo the sine, I take the inverse sine of this side. I take the inverse sine of that side. And if I take the inverse sine of one side, I have to take the inverse sine of the other. And just like any opposite operations do, any inverse operations do, they undo each other. So here, if I take the inverse sine of regular sine, they're going to undo each other, and I'll just be left with angle A. And on the right side, that's how we get the inverse sine of x. That's how we get the inverse sine of x there. I want you to write that down in that space beneath the If we compare this to other problems we might have had, if we compare this to other operations that we could do, if I had something, you don't have to write this part down. If I have, just say, x squared is equal to 64. I want to undo this square to get to the x, right? Just like I wanted to undo sine to get to angle A if we were finding the angle, I would have to undo the square to get to x. What's the inverse operation of squaring we said was? Square rooting. So I would take the square root of this side to undo that. Just like I took this inverse sine of both sides of this side. And if I took the inverse sine of this side, I need to do it to this side as well. Just like if I square root this side, I have to square root this side as well. Just like any operation, when we do it to one side of an equation, we have to do it to the other to stay balanced. And then we said, okay, well, we actually take the inverse operations, undo each other, so we're just left with x. And then here we ended up taking the square root, which would have to be 8. Here, if we had a different number in there, we could actually take the inverse sign of a number. We could take the inverse sign of whatever x would be and put that into our calculator. And we get our angle measure out. Let's walk through the other two first, and I think that'll make more sense in a second. So if cosine of angle A is equal to x, then angle A is equal to, any guesses? Inverse cosine is how we pronounce it, of x. So we say inverse cosine of x. So the inverse of sine is inverse sine. The inverse of cosine is inverse cosine. Does anybody have an idea what the inverse of tangent might be? Okay. Angle A is equal to inverse tangent of x. Angle A is equal to inverse tangent of x. Also, never mind. Is she gonna get over something like this, or is she gonna? If that one comes on, count on something like that. I wouldn't have. I didn't have anything. What are your only socks? Are those unicorns? Nice. I don't think anything like links. It's nice. Okay. All right. So if we flip the page here, hey, what do we notice about this page that we're on? If there's an example page, okay. What about the back of this page? Okay, a test is coming up soon. Heads up. Okay. Okay. So we're done with this chapter after this section. Okay. We're gonna look at a test. We're looking at a test, not next week, but the week after. Okay. Not next week, but our first day of class the week after is when we're looking at. Okay. We're gonna spend next week putting some of this stuff together, finishing this section, and reviewing. Okay.
Someone said that we don't have school on Monday. Is that true?
I've heard that. Be news to me. Yeah.
So the last test for the retakes due next week.
Correct. Or the retakes would be due the day of the test, which is not next week, but the Tuesday after would be the retakes are due. Good question. Thanks for asking that. So on example 1 here, example 1, we're supposed to find angle C if sine of angle C is equal to 0.24. So if sine of angle C is equal to 0.24, I'm going to rewrite this just to give myself a little more room. We need to get angle C by itself, but currently we're taking the sine of it. So how do we undo the sine? How do we get rid of that sine? We take the inverse sine of this side. We're not going to choose inverse cosine, would we?
Oh boy.
We're going to choose inverse sine. We're going to keep it a little simpler than that. We're not going to say like inverse tangent or inverse cosine. We're going to say inverse sine of that. And if I take the inverse sine of this side, what do I have to do to this side? Same thing. Take the inverse sine of this side. Now it's a little bit harder to write that in there because it's quite a bit to write. So I just usually kind of write it up above and put parentheses there in that first step. And then when I do the next step here, I say, okay, those undo each other. We'll have angle C is equal to the inverse sine of 0.24, and that's where I write it. Questions on that step? Not quite done. Nope. The question on this step to get angle C by itself.
Let me guess.
Look at our calculator. Hey, if we look at our calculator, what do we see in like a light blue right above our sign button?
Inverse sign.
Inverse sign. We see that sign of the negative first. We see the inverse sign logo. So if we look at our calculator, we see the inverse sign logo in the light blue right above the sign button. So if you look above sign button, right above right 2 buttons above 7. So you push the second at the very top left of your calculator, that light blue button that kind of matches that color. Okay, you push that top left button, push second, then you push the sign button, and you get the inverse sign. So let's keep it there for now. So everyone getting the inverse sign button. Did everyone find the inverse sign button? Anybody still need help finding the inverse sign button? Okay. Now type in 0.24. Type in 0.24. Has to be 0.24. 0.24. Please close the parenthesis. And then you push enter. And if let's just say for grins and giggles, just to make sure we're all on the same page, let's say, let's round it out to 4 decimals real quick. Can somebody help me round this one out to 4 decimals?
Yeah. 13.8865.
Okay? 13.8865. Now this is an angle, right? We said this was angle C. So what kind of label do we have on angles?
An angle sign?
Degrees. Now, it might be more beneficial for us to say it's the nearest whole angle. But first of all, did everybody get this? Did anybody not get this number? Yeah, let me look at this.
You broke the calculator.
So this is in there, which we need to get rid of. So I just put delete that. So now let's try. There we go. So did you get to that? So you take the inverse, the light blue button. Instead of any of those light blue buttons, push second, and then push the button. Yeah. Okay. So, but if we went to the nearest whole degree, we'd say measure of angle C. The measure of angle C is approximately what whole degree? 14. So we can put that as our answer. I want you to do B on your own, and then raise your hand when you're done or have questions. I want you to do B on your own, raise your hand when you're done or have questions.
B.
B, yeah, example 1B.
Oh. Okay. I'm ready.
Hi, ready? Mr. Crossman. Nice to meet you. I agree.
Your hands are really cold.
They are. So I have this. I would love to actually. I'd love to do that. Yeah, that's why I have this jacket on because I'm really cold. I actually just got a 40 pack of them in the mail yesterday. It was too much. I got a really checks that, which is why I bought that much. So I use them.
How you doing it? Oh, we're doing bees. Yeah.
So we get to go to the nearest one here on that. Do it like you do up here.
It would just be 68. What'd you get?
Journal check page.
You just need to
Zach,
share.
Levi. Oh, you guys back to your seats.
Oh, I asked that,
Oh. Oh, okay, my bad. No, you're good. Thank you.
No, I don't know what you did.
Oh,
Oh, that was-
I can't look at it.
Because it's coastline.
Five and 10. Okay, let's go back to our seats. back to our seats. Okay. So if we come up here, we look at this up here. We say cosine of C, cosine of angle C is equal to 0.37. How do we undo cosine to get just to our angle C? We do our inverse cosine. Mathematically, this is how we do it. Take the inverse cosine of both sides, and then the inverse cosine and the cosine undo each other. Left with angle C is equal to inverse cosine of 0.37. So then you type in your calculator, inverse cosine, you push the second button, you push cosine, you put in 0.37 and close your parenthesis, and C is approximately what to the nearest whole degree? No, but we'll get in a good habit of doing it so that way later on other things it might, you can mess it up depending on how we do it. So to the nearest whole degree, measure of angle C is 68 degrees. Very good. No, we'll unpack up now.
Yes.
You're awesome. Thanks. Sorry. You didn't. Shut up. No, you don't have to. Thank you, though. I appreciate it. Don't need them for other class. If somebody wants to erase the board, they can. What? I got it.
I didn't read you. I thought it was just trying to make